After successfully completing NASA's first uncrewed Artemis mission to the Moon, efforts have rapidly accelerated to develop long-term solutions supporting human activity on the lunar surface. Although the flight testing of the SLS and Orion spacecraft was a significant milestone, it was merely the first step in a complex plan to establish the first permanent human settlements on the Moon. Welcome back to Planetarium, where we unravel space chronicles beyond Earth. In today's video, we're discussing NASA's plan to build the first moon base. NASA's game plan for the Artemis program is continually evolving as they forge new partnerships with private sector companies to develop cutting-edge space exploration technologies. One of the major players in this effort is SpaceX, with their innovative human landing system Starship. Furthermore, plans have emerged for critical infrastructure such as pipelines, roads, 3D printed habitats, and a new generation of extravehicular spacesuits on the Moon. Let's delve into NASA's new plan for its first moon base. It is common knowledge that the first human return to the Moon will occur during NASA's Artemis 3 mission, which they aim to complete as early as 2026. Recently, NASA confirmed their intent to accomplish a second crewed landing with Artemis 4 as early as 2027. The upcoming missions to the lunar surface will utilize a variation of the SpaceX Starship's human landing system. Each of these missions will have a base of operations for 2 astronauts lasting 5 days. This duration will far surpass the previous record for the longest stay on the Moon, held by the Apollo 17 crew in 1972, which was 75 hours. NASA requires a concrete plan for building infrastructure for the next decade of Artemis missions, which will eventually see a crew of 4 astronauts living on the Moon for up to 1 month at a time. Thankfully, the Starship's 9-meter diameter hull and towering height will provide comfortable and spacious living quarters for these early explorations. However, living in the Starship is not a viable long-term solution for establishing a permanent human presence on the Moon. Kathy Luters, NASA's Associate Administrator, has pledged that each new trip to the Moon will offer astronauts an enhanced level of comfort and expanded capabilities to explore and study more of the lunar surface than ever before. In a statement, Luters remarked, "With more demand for access to the Moon, we are developing the technologies to achieve an unprecedented human and robotic presence 240,000 miles from home. Our experience on the Moon this decade will prepare us for an even greater adventure in the universe, human exploration of Mars." In January 2023, NASA disclosed a novel initiative to lay a pipeline on the Moon. This lunar South Pole oxygen pipeline would become the first permanent human infrastructure installed on the Moon, serving as a significant initial step towards in-situ resource utilization. The primary objective of the pipeline is to transfer high-purity oxygen from a production source to a storage plant located near the future moon base. NASA has already created a process dubbed molten regolith electrolysis, or MRE, which they will leverage to extract specific elements from the lunar dust containing a significant amount of stored oxygen. NASA intends to use the oxygen extracted from the lunar dust to supply human habitats, pressurized rovers, and launch vehicles departing the Moon. To achieve this, NASA plans to build a 5-kilometer-long pipeline to transport high-purity oxygen from a production source to a storage plant located near the future moon base. The reason for making the pipeline is that moving the stored oxygen around the surface on rovers would be more energy-intensive than extracting the oxygen in the first place, rendering the process unsustainable. The pipeline would support a flow rate of 2 kilograms of oxygen per hour and could supply a moon base with up to 10,000 kilograms per year, the projected amount required for a self-sustaining base. To manufacture the pipeline material, NASA plans to use in-situ aluminum metal obtained through molten regolith electrolysis, or MRE. NASA plans to demonstrate these oxygen extraction technologies on a large scale on the Moon as early as 2024, providing direct support to Artemis astronauts as early as 2026. NASA granted a $57 million contract in November 2022 to Icon, a leader in advanced construction technologies and large-scale 3D printing, to develop a lunar surface construction system. Icon achieved the first fully 3D printed house in the United States in 2018, and in 2021, they began working on Mars Dune Alpha, a 3D printed habitat at the Johnson Space Center in Houston, Texas. This 1,700 square foot structure simulates a realistic Mars habitat, which NASA astronauts will use in training missions to prepare for long-duration trips to deep space. ICON's latest effort, Project Olympus, aims to research and develop space-based construction systems to support the planned exploration of the Moon and beyond. ICON's Olympus system aims to use local resources on the Moon and Mars as building materials to support NASA's efforts to establish a sustainable human presence on the lunar surface. The process involves using lunar regolith, which is melted and mixed with a cement-like substance that a fully automated 3D printing robot can lay down. The multi-purpose construction system supports various needs, including building habitats, landing pads, and other infrastructure for future missions. To develop their manufacturing process, ICON has been provided with samples of real moon dust that were collected during the Apollo program. The regolith is mixed with a resin-like chemical that can be cured and hardened by UV radiation from the sun, similar to the process used to fix dental castings. Project Olympus's first demonstration is scheduled for 2026, which will be a significant achievement for human civilization, as it will be the first ever constructed habitat on another celestial body. ICON is also working on a lunar infrastructure system that includes landing pads and roads. These elements are essential for reducing the impact of human activity on the lunar surface. The engines of the Starship during landing and the movement of rovers and pressurized vehicles can stir up a considerable amount of dust, estimated to be up to £1 million. Placing solid landing pads and roadways is a better option to minimize this impact. The upcoming lunar rover, the Lunar Terrain Vehicle (LTV), is expected to utilize the newly constructed moon roads. The design of the LTV is similar to the side-by-side all-terrain vehicles (ATVs) used for hunting and farming. They can be driven by an astronaut or remotely controlled. They're scheduled to be deployed on the lunar surface after Artemis 3, possibly as early as Artemis 4. NASA is exploring the possibility of making the LTV an autonomous vehicle, allowing it to continue conducting scientific work, even when no humans are on the Moon. This makes the LTV a critical tool for searching for water, ice, and other lunar resources, which will help NASA determine the best location for the more permanent components of the base camp. NASA's Habitable Mobility Platform is set to be the first ever pressurized rover with an independent life support system, allowing astronauts to operate the vehicle without the need for spacesuits. This would enable them to explore the lunar landscape longer, potentially for hours or even days. The HMP is slated to arrive on the Moon between Artemis 5 and 8, providing another valuable tool for lunar exploration and resource utilization. NASA faced significant challenges in developing new spacesuits for the Artemis program, which is crucial for achieving its goal of returning humans to the Moon. Despite debuting their next-generation spacesuit concept several years ago, they struggled to manufacture them at a reasonable cost within the required timeline. Ultimately, the old spacesuit design had to be abandoned, and NASA contracted Axiom Space, a private American aerospace company, to develop a new spacesuit. In September 2022, NASA awarded Axiom Space a contract worth $228 million to design and manufacture a new spacesuit for the Artemis program. This was necessary as the previous next-generation spacesuit concept ran into manufacturing issues that could not be resolved in the required timeframe. The new design is expected to be unveiled in the spring of 2023. Unlike the spacesuits used for spacewalks at the International Space Station, these new suits need to be specifically designed to withstand the unique conditions of the Moon, such as its gravity and sharp abrasive dust. During the Apollo missions, lunar regolith posed a challenge for astronauts as tiny shards could penetrate their suits, causing discomfort. This was because there has never been liquid water on the Moon, and therefore the rocks on its surface are not as smooth and round like those on Earth. Instead, they are sharp and uneven, making it essential for the new extravehicular suits to withstand and resist such abrasive dust. Observing the progress of these endeavors as they come to fruition over the next 10 years will undoubtedly be awe-inspiring. Humanity's development as a species inhabiting multiple planets is currently underway and progressing one step at a time. However, what do you envision a moon habitat will appear like? Share your speculations in the comments below. Don't forget to like the video to support us and subscribe to our channel, Planetarium Beyond Earth, for more videos like this.